So, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video. With me, Coach Goo. And I was on KOTV today, guys. Get a load of that one. Okay. Anyways, last week, we did multiplying and dividing rational expressions. Today and tomorrow, we're going to be doing adding and subtracting rational expressions. Alright, so today we're going to mainly be focused on this very important concept right here. Read the first line. When you're adding and subtracting rational expressions, remember they're fractions, you must have a common denominator. You guys remember learning how to add and subtract fractions like in 8th or 9th grade or whatever? You can't add or subtract fractions until what? Unless you have? Yeah, the same denominator. So the same thing applies here. Okay? So basically, you're multiplying the top and the bottom of a fraction so that the denominators of both fractions are the same. They have to be the same. Alright, remember you don't have to do this for multiplying and dividing, but you have to do this for adding and subtracting. So let's take a look at some simple examples. First, we're going to start off with just practicing finding the least common denominator. That is what we call when we make the denominator the same number, right? So, right here, look, we've blanked out the numerators, right? We're not worrying about the top. We're only worrying about finding that least common denominator. So, we're trying to find a number that both of those denominators can become so that they're the same number through multiplication. Alright, look at A. The denominators there are 12 and 4. What number?
4 times 3.
Right, and that would take you to what?
Gives you 12.
That gives you 12, right. And so our least common denominator on A would be 12. How would I get that? The fraction on the left, it's already 12, right? So we don't need to change that one. But, like you said, that's right. On the right, the 4, what do you have to do? Now be careful, let's get in the habit. You can't just multiply the bottom by 3, right? You gotta do the top and the bottom. So let's go ahead and write it like this. Obviously right now we're not worrying about the top, but let's just get in a good habit here. So 4 times 3 like that is gonna give me that 12. And so 12 is my LCD, the least common denominator. That is a 3.
Wait, so 3 over 3?
3 over 3, yes. Because you're only allowed to multiply by the number 1. 3 over 3 is technically the number 1. So let's look at B then. Does anybody know what the least common denominator on B would be?
Wait, so 12 is the answer, right?
Yes, because we're looking at the least common denominator. Remember, you have to multiply up to make them into the same number. We're not dividing.
30?
30 is the number.
That's what I said.
Oh, I thought you said 3.
Yeah, I thought you said 3.
Yeah, see, he says right behind you and he said you thought 3. All right, so it's 30. It's 30, but how do I make each of these into 30? Let's just practice here. How do I get 10 to 30? So I got to do 3 over 3 to get 30, right? And then how do I get this 15 to 30? 2 over 2. So right, the least common denominator is 30. Very good. 2 over 2, you can only multiply it by 1. All right, so what is the least common denominator on C? It's 18, right? And how am I going to get that? 1 over, right, so the 18, I don't need to do anything with that. It's already 18. But what do I have to do with that 6? 3 over 3, very good. I like how you're the only class that he was actually saying 3 over 3. Everyone else just says 3. Alright, so 18. That's right, is the least common denominator. Okay, so finding the least common denominator when you're just given numbers is not that bad. So let's go into when you're actually given the variables as well. Now here's the thing though. When you're starting with the variables, just like we did with multiplying and dividing, you have to tell where this expression is going to be undefined, right? We don't want undefined. Undefined is not something that we can calculate. So, but it's the same thing, that we find it the same way. So right here, x cannot be what? What would x have to be for this to be undefined? 0. How did you get that? Remember, you set the denominator equal to 0, right? 12x equals 0, so x has to be 0, right? And just letting you know right now, it's always going to be 0 unless you have like a plus or a minus something past the x term. If it's just that term by itself, it's going to be 0. Okay, so now let's find the least common denominator.
Plus or a minus, it would be like a fraction.
Yeah, exactly. You'd have to solve it out. It might be a fraction. Okay, so now let's find the least common denominator. What is the least common denominator on D? What do you think it is?
Wait, we just did D.
We didn't do D yet. This is telling where it's undefined. Now we're looking for the least common denominator. 36. Is it 36? Let's see. It's not 24. 36 though. Alright, so 12. How do I get 12x to 36? Times 3. Okay, so, but what is 12x times 3? 12x times 3.
Oh, 36x.
36x. There's no way you can get 36. So 36 is not going to be the least common denominator. That's close. It's 36x. Yes, you have to include that x, right? There's no way you can bring the 12x down to just the 36. So when you have to include your variables in your least common denominator. So that's what we were making both denominators equal. You're trying to get it to 36x, right? And usually it's just going to go by the highest variable. All right, so that is going to be the answer. But let's see, how do I get 9 to become 36x? Times 4x, right. So you see, sometimes you have to multiply by an actual variable, right? So the least common denominator here is 36x. All right. Let's look at E then. On E, what can x not be?
0.
0, right, same thing.
I have a question.
Yeah.
You guys show the work on the test?
Uh,
Just do one side.
Yeah, if you just need to do one side, you don't necessarily have to. Yeah. All right, so what's the least common denominator on E going to be?
Basically. Unless it has a plus or minus.
The least common denominator is the denominator that you're trying to make both of them into. What's it going to be on E?
144?
Whoa, that's a big number. 36. And what about the variables? X squared, that's right. Because, okay, you know the number's 36, right? So how do I get 18 to 36? Times 2. But look at this. If I multiply 2 and 2, what's 18x squared times 2? X squared, right? So now you see, oh, wait, I actually have to make 12x into 36x squared, right? So then how do I make 12x into 36x squared? Times 3x, right? And so your least common denominator here is actually 36x squared. Because we have an x squared on the 18, there's no way to get rid of that x squared, so you're going to have to end up with x squared in your denominator. All right, on F then, what is x not equal to on F? 0, yes, it's also 0.
Is it 0 to 1?
I mean, in our examples today, mostly it's going to be. That's because they didn't add or subtract any numbers, you know? So it is 0, and what is the least common denominator here? Do you know? 20x cubed, that's right. How do I get 10x cubed, 20x cubed? Times 2. Because you can see when you multiply by 2, that gives you 20x cubed. And then now you see, oh, I have a 20x over here. How do I get 20x to become 20x cubed? What do I? Right, multiply by x squared over x squared. Gives you 20x cubed. So then your least common denominator is 20x cubed. And let's go on to the last one then. On G, you can see there are 2 variables here, right? So that means that when I write my limitations, my restrictions, I need to write 2 variables. It's going to be x, comma, y. Make sure you put the comma, right? That's showing that you have 2 different limitations, 2 restrictions, right? If you just write x, y, that makes it look like if I multiply x and y together, it can't equal something. But it's x can't equal something and y can't equal something. So what can it not equal? 0, that's right. All right, so what do you do? How do you find the least common denominator when you have 2 different variables? What do you think? Not going to be 1 because that would not, you can't make them equal 1.
You just multiply the other one by the variable?
Yeah, you just multiply them together. Right? X times y equals what? xy. And then watch how this works. If I chose xy as my least common denominator, how do I get y to become xy? What do I multiply by? Just x over x, right? And how do I get x to become xy? Right, multiply by y over y. So yeah, if you have 2 different variables, you can just multiply them together to get your least common denominator. And that's it. So in this section, all we did, we're just focusing on finding least common denominators. That's because we can't add or subtract until we can find this. So if you don't know how to find this, the lesson doesn't go on. So now let's go on to the example 2 where we're actually adding and subtracting, starting with just basic fractions. Starting with just basic fractions, all right? So remember, I can't add or subtract these fractions until the denominator is the same. So on A, notice the denominator is not the same. So I need to find that least common denominator, which would be what? 20, that's right. So with the 3 over 4, how do I get the 4? What do I multiply the 4 by to get 3? I mean, to 20, what the? 5 over 5, right? And this is where it's actually important to write it like that, because now you see I'm multiplying 3 over 4 by 5 over 5, which makes it into what?
15 over 15.
15 over 20, right? Which is completely different than 3 over 20, right? Okay, so now with the 4 over 5, what should I multiply that by to get the 4 over 4? The denominator we're looking for is 20, right? So yeah. When I multiply by 4 over 4, what do I get?
16 over 20.
And so now my two fractions are 15 over 20 and 16 over 20. So what am I actually doing? Oh, why am I writing 60? Whoa. 15 over 20 minus 16 over 20. Now that the denominators are the same, I can actually subtract, right? So what is my final answer?
-1.
That is correct. Very good.
You want to do like x doesn't include.
There's no x's here.
Someone's at the door.
Yes.
Mr. Cool.
That's me.
Hi.
Hey.
I'll speak to you real quick. I'm Miss.
Hang on a second. All right, on B, what do you notice weird about letter B? What do you notice strange about B? There's no fraction on that 2, but how can I make that 2 into a fraction? Put it over 1, right? And if it's over 1, what is the least common denominator? 6, right? So I multiply by 6 over 6, which makes this fraction into what?
12 over 6.
So 12 over 6. So now I'm doing 19 over 6, right? Which would be?
7 over 6.
That's right. 7 over 6. Very good. Yeah. Well, I mean, you know, you learned this back in 8th grade or something like that, so I'd hope that you can do it now. Okay. Bye. All right, C. What is the least common denominator on C?
15.
15. So what do I need to multiply 2 over 3 by?
5.
5 over 5, which gives me
10 over
10 over 15. What do I need to multiply 3 over 5 by?
3 over 3.
Which gives me?
9 over
15.
And so now what am I actually doing here?
10.
Right? Right, which is 1 over 15. Nice. And on to the last one on D. What should I do first on D? Put a 1 under the 2, right? And then so what is the least common denominator? 7. So what should I multiply 2 over 1 by? 7 over 7. What does it become?
14.
Right? And so now what am I actually doing?
3 over 7 minus 14.
Which is?
-11.
That is correct. Very good. Negative 11 over 7. All right, so let's turn to the back page. Let's actually get into these rational expressions now. Let's get into the rational expressions. I'm going to reopen this page because my computer's been messing up all day. All right, so on the back now, we're including the variables. So the very first thing we have to do is write our restrictions. So look at A. What would the restriction here be? X cannot equal 0, right? All right, so now we're going to find the least common denominator. What is the least common denominator in A going to be with the variables? 12
X squared.
x squared, that's right. We already see that 7 over 12x squared, that's where we want it. But how can I make the 6x into 12x squared?
Times 2 times 2x.
Times 2x over 2x, right, which makes this what? 10x over 12x squared, that's right. And so now we're going to have 10x over 12x squared minus 7 over 12x squared. Now notice right here, what? There's no x on the 7, right? So can I combine the 10x and the 7? No. So all I have to do is rewrite this as a single fraction. That's right. 10x minus 7 over 12x squared. Very good. So all I have to do is rewrite it as a fraction. I would highly recommend writing this step right here before right, because you're going to see as we get more complicated examples, if you don't write the step out, you might make some mistakes. So it's always better to show your work, but you know, I can't hold your hand and make you do it. So Let's go to B then. On B, what are my restrictions here? X is not equal to 0. That's right. Very good. Oh, that looks like a 6, 0. All right, and what is my least common denominator on B going to be? 18 x squared. That's right. So how do I get 9x squared to 18x squared?
Times 2x. No, times 2.
Times 2 over 2. Which makes this what?
18x squared over 4 over 18x.
Right, 4 over 18x squared. Very good. And then what do I need to multiply the 5 over 6x by? 3x over 3x. Which gives me?
15x over 18x squared.
That's right. And so now I have 4 over 18x squared plus 15x over 18x squared. So what's my final answer?
15x plus 4 over 18.
15x plus 4 over 18x squared. That's right. Very interesting. Why did you say, is there a reason why you said 15x before the 4?
Because it doesn't have the, because 4 doesn't have a variable.
Right, because so you're pretty much going from highest degree to lowest degree, which is technically, the best way to write it. It doesn't really matter if you write it the other way as well, but technically it is better to go from highest degree to lowest degree, so anything with x's first, and then the numbers last. So very good. 15x plus 4 over 18x squared. All right. Next. C. What are my restrictions here? X cannot equal
0.
0. And what is my least common denominator here? 12. What? 12x. Right. So how do I make 3x into 12x?
4 over 4.
4 over 4 gives me
8 over 12x.
8 over 12x. And what do I need to multiply the 5 over 12 by?
X over x.
X over x. Right. Which gives me 5x over 12x. Right, so now I've got 8 over 12x plus 5x over 12x. What should my final answer be then? That's right. Very good. Nice. And on to the last example in this section. What should x not equal in this last example, D? 0 should not equal 0, right? And what is my least common denominator here going to be? 40x squared, right. So how do I get 8x to 40x squared?
5x over 5.
Which gives me?
25x over 40x squared.
That's right. And then how do I get the 10x squared, the 3 over 10x squared? How should I?
4 over times 4.
Times 4. Which gives me?
12 over 40.
Right, so we multiply by 4 over 4, gives us 12 over 40x squared. So now I've got 25x over 40x squared plus 12 over 40x squared. What is my final answer? That is correct. Very good. Nice. Okay, and now on to the last section then. Example 4, same idea, except now we've got different variables right here. All that changes is how we write our restrictions and then finding our least common denominator. So what is my restriction on A going to be here? What should I write?
Y. I mean x, y.
How should I write it?
X, y.
X comma y. There we go. Not equal to?
0.
0. That's right. Good. Okay, what is my least common denominator here going to be?
X,
xy. How did you find that? How did you know? Yeah, you just multiply them together. That's right. So how do I get 3 over y to have that denominator?
y over 3.
X over x? Which gives me what?
3x over y.
Let's put it in alphabetical order, x, y. And then how do I get the 5 over x to be xy?
Y over
Y over what?
1.
Okay, so that gives me over?
Over x.
That's right. And so now I'm left with 5y over xy minus 3x over xy. What's my final answer?
3x
Would be 2xy over xy.
What?
It's just 2x over x.
Wait, what? This is 5y over xy minus 3x? You can't-
5y minus 3x over xy.
Yes, you just rewrite it exactly as it is at one single fraction. Sorry. Just giving me weird stuff from another dimension over here. Alright, yeah. 5y minus 3x over xy. There you go. Yeah, right, because you can't combine them. They're not like terms. They got different variables on them, so we just rewrite that as a single fraction. All right, last one, b. What is my restriction on b going to be? Right? Not equal to? 0. Very good. What is my least common denominator on b going to be? 4ab. Very good. So, how do I make this 2 over a into 4ab? Times 4b over 4b, which gives me? Over? 4ab. Good. And then the 3 over 4b, what should I multiply this fraction by?
A over A.
A over a, which is?
3A
Over?
4A.
Right. And so now I'm looking at 8b over 4ab plus 3a over 4ab. So what is my final answer here?
Maybe 3A plus 8.
You can write it either or. It just really doesn't matter. You know, if you like putting it alphabetical, it's fine. But leaving it in this order is probably easier here. 8b over? That's right. And so that's it right now. We're just starting pretty simple today, and tomorrow we're going to go a little more in-depth with it, but that's all it is for today. And so that's going to end these notes, guys. So until next time, see you in the next one. Peace!